All right, so shh.
Yeah. Imagine opening it for I was forced to say
All right, so shh. What we're gonna do is, guys. What we're gonna do is we're gonna talk about inverse derivative. Your test will not be tomorrow, because I need to talk about two more things. It was supposed to be planned on last week because, but I was sick. But I want to decided to put more things on it. So now you have a little bit more things, and test will be on Thursday. So those two things. The two extra things are not that hard. So we're gonna start with the inverse derivative. So inverse derivative. All right, can you find the inverse derivative of this? This should be easy to find derivative inverse. Or do you guys remember how to find the inverse? All right. If you want to find inverse function, just make y is equal to 2x to the third minus 1. I didn't do anything. I just changed f of x to y. And I switched the x and y. Where's Luke's? Luke's not here today?
He is.
He is?
Yeah.
I didn't see him.
He's skipping our class.
No, he's not a bad kid. Huh?
He was. Yeah. He does percussion for MBA.
Oh. Now, it's gonna be y cubed equal to x plus 1 over 2, and then y is equal to cube root of x plus 1 over 2. Does that make sense? And that's the inverse function, so we can denote as the third roots of x plus 1 over 2. I mean, everybody in this room, it should have no problem finding the inverse function. I just basically switch to the x and y and solve it. Questions? You've done this last year, right?
Yes.
Okay, so go ahead. Okay. I would like to talk about inverse function is super important. The reason being is super important is we use all the time. For example, square and square root, they're inverse to each other. What else is inverse to each other? Not log and ln, but log is good. Log and exponent, and ln and e, right? Then there's sine inverse. There's cosine inverse. So there's a lot of functions are inverse to each other. It's best to know they are interact with each other. how do they interact is very crucial. So there is also a way for you to prove that this and this are inverse to each other. How do you prove? So prove those two functions are inverse to each other. So prove that this and this are inverse to each other. How do you prove it? The prove it is basically just do f of f inverse of x, like this. If it come out equal to x, then that is proof. So for example, I'm going to take this function and I'm going to plug in to this x. So I'm going to plug into this x right here because that's inverse function. I'm going to plug an inverse function into the original function. So if I do that, right, if we f of f inverse of x, if I do that, I'm going to get 2 x plus 1 to the 2 to the third roots to the third power minus 1. So third root to the third power, they cancel each other out. And then 2 cancel out. And eventually equal to x. And that's, we just prove that those two functions are inverse to each other. And you learn this in pre-calc. I don't know my class taught it or not. I know you should have learned it. But if I did not teach you, that means I probably missed something. And I did. I believe I did last year, missed to teach this part, to talk about the inverse. So this year I actually do it again. Make sure I did it. Last year I was kind of worried about a lot of other things. So this year I was just kind of focused on pre-calc material. In my class, we actually had to learn conics. But other class doesn't have to learn conics. So I was too busy teaching on stuff it's not on the test. So in order to verify if they're inverse to each other, you can plug in one function into the other function. You can do it the other way too. You can plug in this. You can plug in this thing into here as well. It should come out as x. If it come out as x, then they are inverse to each other. Is this okay?
Yeah.
What else we need to know? What's the relationship between original function and inverse function? Do you guys know the relationship? No. They are like this. No, they are like this. Pay attention, they're like this. X and Y, they go like this. They're not reflection. They are just swap. So I'm trying to say is pay attention to this graph. Okay, pay attention to, oops. Pay attention to two things. One is the green line. Sorry, well, I don't know why there's a black line here. Oops. Why are you laughing? So I hear, first of all, the red line is the original function, and the blue line is the inverse function. Now pay attention to their table. What do you discover? The x and y is a flop, like they switch, right? They switch. Think about this and this. Look at that. They're exactly mirror image out of y equal to x. Y equal to x is the symmetry line for the inverse function, always. And you can pretty much pick any coordinate like this. They are just completely swapped. The relationship is x and y flip. very, very important that you recognize that. Look at this point all the way up here, and look at this point all the way here. See, what the relationship on all of them. Now, this one cannot flip because 1 and 1 cannot flip, right? 1 and 1 flip is still 1 and 1. So that's why they intersect that point. They don't always have that intersection, but sometimes they can have intersection. But for example, the one function doesn't have inverse to each other. That one function is inverse to each other, they don't have intersection. It'll be like natural log of x and e to the x. They are inverse to each other. So one of the biggest thing that we study is, let's say, ln of x and e to the x. Right? Look at this. Let's get rid of those two. And they're inverse to each other. Again, the coordinate is completely swapping. But right now, we just focus on, don't worry about e to x and natural log of x so far. We just focus on this. Do you understand that x and y swap? Very, very important today. The only thing you have to understand is x value and y value, they swap. Position swap. Now, let's look at the derivative. Let's look at the slope. All right, imagine I have a slope at -1, 3. And if I have a slope at -3, -1, what will be the relationship between two slopes? Like, what would you think the relationship between those two slopes? They're reciprocal. Very good. But you have to pay attention how to operate it. Pay attention. Now, for example, we're going to take the first coordinate, -2 and -17. We say g prime of -2 is equal to 24. Do you see that? G prime of -2 is equal to 24. But we cannot do g prime of -2. We have to do g prime of -17. Austin, are you paying attention to me? You're on your phone. This phone should be out of window.
Yeah.
I've been throwing phone out of window.
I'm not on it.
Okay.
I throw Nelly's phone out of window.
Really?
Nelly, yeah.
Oh, what did she do?
She was playing
Blast. Yeah.
Blacklist. Yeah, she's addicted to that game. I was like, Nelly, let me see your phone. Come on, Mr. Yeah. Why am I on his phone?
There's the winners of this class. I'm very wary of what I do.
Thanks, Shady.
I'm not gonna lie.
You always are very good at hiding it, though. All right, so do you see that f prime of -2 is equal to 24, but g prime of -17? Why is -17? Because -2 and -17 is the inverse relationship. And same thing as slope is reciprocal relationship. Now, one is xy swap, and one is reciprocal to each other. Is this okay so far? Okay, so
Confused on how you got -2 and -7.
I just plug in -2 into the original function. If I plug in -2,
Oh, it's just
that's gonna give you -2 to the third power. It's gonna be -8. -8 times 2 is gonna be -16. -16 minus 1 is gonna give you -17. But however, if your inverse function, if I plug in the x is -17, then output is gonna be -2 because the x and y swap. But the slope are reciprocal. That's a very, very important. So that comes down to, it tells me one thing. It tells me on any particular point, and not only one point, it applies to all the points. On every single point, there is some type of relationship. Let's just assume g of x is equal to f inverse of x. Okay, let's assume the g of x is inverse of x. Therefore, this is a very, very important equation you have to know. G prime of x is equal to 1 over, this is the inverse, right? Let me pay attention to tell you that this is the inverse derivative. Inverse derivative is equal to f prime of g of x. This is a reciprocal part because of 1 over f prime of g of x. Another notation is a little bit confusing, but some people prefer this notation because they don't have to deal with g of x. So another notation that I can do is I can set f inverse of prime of x. Does that make sense? F inverse of prime of x is equal to 1 over f prime of f inverse of x. And that's another way to think about it. But either equation, you just have to know it. It's actually fairly easy. So usually this question, when I was a student, I struggle a lot because I wasn't really bright when I was in high school. I'm still not very bright even till now. So no, it's okay. I openly admit that I don't really care. You know, like there was a very good quote to make fun of teacher. Yeah, those are people who can't teach. Like Kent, like CANT. Can't. Those people who can't teach. Right? Those people who cannot play, they end up be coaching. Right? You don't see Michael Jordan coaching somebody, right? You see Michael Jordan playing a basketball game, but you don't see the Michael Jordan coaching. Like Michael Quick, what's it? The Duke coach, Mike Shasa, what Mike? Now Kozowski, no. Mike, like I don't know, Spurs, Phil Jackson. Phil Jackson is like one of the best basketball coach, but he's not the best basketball player, right? Those people who can't teach, so that's how you make fun of teachers. So that's me. Those people who cannot do math, then that's why I'm teaching, because I'm better at communicate people who doesn't know how to understand the math. So I don't mind. Yes.
Don't like. I don't have an example. But it just cancels out.
No, they don't cancel out because the prime and inverse are different. So are you talking about this two will cancel out? No.
Like the denominator.
F prime of g of x. Why is that? This is prime. This is not inverse. If it's the inverse and the f, they will cancel out equal to x. But this is not. This is a derivative. Does that make sense? Okay. So yeah, if you ever want to make fun of teachers, those people who can't teach. But that's a very mean thing to say, though. But yeah, you can make fun of me. I don't really care. So now you're gonna say, why do we do this? Why we need to find out using this function? You could have said, Mr. Ye, I could have done just, I know how to find the inverse function, and I'll just take a derivative of it. And I plug in the value, right? Why do we bother to use this information? Always asking question why, because why are we doing this? I can find inverse in like 3 seconds, and I can take a derivative in like 20 seconds. So I could have spent 25 seconds to figure out the inverse derivative. So then I say, well, what if the question is like this? So previous question, I can find the inverse and I can take a derivative because I could easily take a derivative of this function, just use chain rule. Now this question is different. This question says, hey, f of x equal to x cubed plus x minus 1. And not only that, I want you to assume that f inverse of x equal to g of x. And I want to find out what is g prime of 9, right? I want to find out g prime of 9. And that will be the question. But do you see that it's possible for me to find inverse or no? Is it possible? Is it possible?
You can't isolate.
Ariana, what you say? Ariana, what you say?
Well, I was saying if it's like multiple y's and you flip the variables and you can't solve for like one y.
Yes, exactly. You're right. So x equal to y to the cube plus y minus 1. I can move the 1 over, and my idea is to solve for y, right? But you're like, oh shit, I stuck. Because I cannot factor out a y. If I factor out a y, then that's not going anywhere. So y squared plus 1, how do I get y by itself? Because if I move the y squared to the other side, I'm not isolating the y. And I cannot combine y cubed plus y into 1y. So we said, well, this is not possible. Not possible to isolate. So that's why we need an inverse derivative helps. We say, well, this is not the best way. However, what we can do is we can say, okay, well, this is not too difficult. We can find a way to around it by using this equation here or this equation here. Now, why is two equations? Well, one equation just write everything in terms of f. The other equation is right in terms of g of x. So there's a difference between f of x and g of x. And you know that g of x is equal to f inverse of x. So then you say, okay, well, I'm going to start this and I'm build a gadget. The gadget I built for this particular questions, for this particular type, I'm going to have an x and a f of x. And we're going to have x and g of x. Why? Because is this x value or y value? This 9, is that x value, y value? It's an x value for the inverse, right? So I should be 9 here, right? This should be 9, right? G prime of 9, that should be the x value, because that usually parenthesis is inside the x value. But this x value is going to interact to the becomes the y value of the original function. And also, we don't know what this value is. So that means I can plug in 9 is equal to x cubed plus x minus 1. Yes. So because we find out this, we can say, hey, that's also equal to that. So that means I'm moving the 1 over. I'm going to get 10 equal to x cubed plus x. Now you're going to be like, Mr. Ye, I never learned how to solve this. And truthfully, I don't know how to solve this either. But there's one last thing that you can do when it comes down to desperation. Usually think about a number that you can plug in to hold true. So it's guess and check. X cubed. So we can guess and check here. Guess and check. So of course we can get 1, but 1 cubed plus 1 is equal to, Laura, I cannot teach you why you like that. So can you hold it? Okay, so we can guess 1, but 1 doesn't work. So we can guess 2. 2 to the third power is 8. 8 plus 2 is 10. So 2 works. So we know x is equal to 2 is true. So, but guess what? Well, we discover that this is equal to 2. But if it's 2, then we know what g of x is now. Now remember this equation, right? Copy and then paste. And we say, okay, we want to find out g prime of 9. So that's going to be g prime of 9 is equal to 1 over f prime of g of 9, right? What? So that's what a g of 9 is 2, right? Does that make sense? Now, can I just worry about, hey, let's take a note of this because that's f prime 2, which is easy. F prime of x is equal to 3x squared plus 1. And f prime of 2 is equal to what? 13. So it'll be equal to 1 over 13. And that will be the derivative at g prime of 9. So through this inverse derivative formula, we can find the derivative at any x value, long as we can resolve to finding what the y value is at first place, or at the x value if you are placing y. Yeah. So this is going to be 1 over 13. Now this gadget is this table is very important to help you. So this table, I think, is very helped me because, like I say, I'm not very smart, and I have to figure out my own logic to figure out a way to build my puzzle, so I can figure out, okay, this is how am I going to solve the problem, because that helped me. Hopefully it helped you. We're going to try a question. So, and you're going to be like, Mr. E, I cannot do math competition. But right now, I'm going to ask you to do math competition questions. Okay, so this is question 16. And you're like, oh, math competition, I'm done. That's not for me. But I believe most of you guys can solve this problem. 16, it's multiple choice, cannot be that hard. So question 16 is a math competition that we did in OSS. The funny thing is I didn't get to teach this question before we got there. I was trying to teach outside the thing, but I didn't have enough time. But I know that all the competition have the same question. It's this one. It's the inverse derivative. Yeah. Building that table will help you, I promise you. Peter, you got it?
And that's the one. And then you just try it. 38.
Stock market probably crashed today.
38.
Let's see how fast stock market crashed today.
Oh.
Oh, it didn't crash. That's crazy.
My birthday month.
Is it X?
Huh? I don't know. Did you guys get the same thing?
Oh. When you plug it back in, or it's found it in the original function. Yeah, but they're inverse. That's why the table. Use the four inches because you can take it out. And then, yeah. And then you plug it.
Oh, cause it's one over.
I'll never do it.
The answer should be A. Do you guys get A? Okay, let's look at the question. It says f of x equal to x fifth plus x to the third over 4. And then say g of x equal to f inverse of x. And they say g prime of 10. So that means I have x and f of x. And I have x and g of x. And this is 10, sorry. This is 10. If it's 10, that reflect this is 10. So that means 10 equal to x to the fifth plus x to the third over 4. Sorry. And that's equal to 40 equal to x fifth plus x to the third. Obviously, that you can try 0, 1, and 2. But only closest one is actually 2. So 2 to the fifth power is 32. 32 plus 8 is equal to 40. So x must be equal to 2. So that means this is equal to 2. But that also implying this is also equal to 2. So now we're going to say, well, that's going to be this. So I'm going to write down the equation. G prime of 2 is equal to 1 over 1 over what? F prime of G of 2. G of 10, sorry. And that's gonna be 1 over f prime of 2. And which is we can easily take a derivative of that. So that is equal to 5x to the 4th over 4th minus 3x squared plus 3x squared over 4. And if I plug in 2, that's gonna be 80 over 4, so 20 plus 2 squared is 4, 4 times 3 is 3, so it's 23. So the answer is 1 over 23. And guess what? You just finished your math competition questions.
For the question, it should be,
yeah.
you put G prime is 2, but it should be G prime is 10. Like G prime is 10 and equal.
G prime of 10, yeah. Sorry. Did I hear it right?
Or you, yeah, I'm pretty sure you understand.
Huh?
How much time would you have to
Well, the idea is a math competition, you don't have a lot of time. Because there was a lot harder question. This will actually considerably easier question. So I will say this question, like ideally you want to solve in 1 minute. But the problem is other questions gonna take 3 minutes or 5 minutes. So so like say for set 17 it's actually pretty easy. For 18 is actually something that we can do now. So they are all possible. So 18 will be a great question that if I had to say, so let's put this on the test, that'll be a very good questions. But because now you can actually manage that. The problem is like a lot of times we don't get to teach those stuff. That's what happened. I mean, we haven't get there yet for the math competitions. Well, by the next year you should be like excellent at it. Yes, Amara?
Would you ever see mixed variables? Like with f(x), would you see like x plus y or something?
What do you mean?
Like,
Okay.
I don't know, would you ever see like an x and a y on one side? And then have to do something different?
Not in inverse, but you can in competition, but not in this is probably the hardest question they will give you an AP exam.
This one?
Yeah, this one will be the hardest question because this is a competition question. Competition is right here, and AP exam is right here. So if you can do this question, a lot of time they will give you the value already. They will say, so yeah, G prime of 10 is equal to 2. They will even already told you that. They won't even like on AP exam, they will even like just give you all the information, just like knowing what to do. They even give you a table or the value. You just have to figure out which one is which. Today you're gonna get to some practice of that. You're gonna have to see it. But it's actually easier in terms of this one. But no, you're not gonna have something more complex than this. Okay, so let's talk about this is the inverse derivative. But we're also gonna talk about another thing that's really difficult. How much time we have? 6 minutes. Okay, this is very easy. Okay, thank you. Derivative e to the x is very difficult. You guys ready?
Wait, no.
It takes like 2 seconds. Derivative e to the x. Okay, derivative of e to the anything other than x, then it's gonna be e to the u du dx. So how would I take a derivative of this? E to the negative 3x. What do you think e to negative 3x is going to be? No. Gia, you're doing good. Keep on going.
E to the negative 3x times.
Shh, Gia.
What did I say?
You're doing good at the very beginning. I don't know what you say.
I don't know what I said either.
It can really help you if you don't know what you say.
Right?
Oh. Time. Wait, negative 3.
So this is the u, right? What's du?
Negative
Negative 3.
You're actually
I'm sorry. Okay, what will be e to the 2x cosine of 4x?
She was so happy to answer everything, but now she's quiet. It's emotion.
got it.
You must do something. This is a little bit good. Good start.
Oh.
Yeah, because there are two functions multiply each other. You gotta be able to see that right away. Is there are two functions multiply each other. Therefore, it must be a product rule. This is a question actually on the AP exam in the past before. Just take a derivative of this.
What's the sound of not?
So first of all, you had to see those two parentheses multiply each other. Do you see that? How do I take a derivative of this? Well, 2e to the 2x, right?
Yeah.
Times cosine of 4x plus e to the 2x times negative sine of 4x times what? 4. Don't forget that because there's a chain rule. There's a chain rule, right? So that's it. You're done. You can even factor out e to the 2x if you wanted to. So it'll be 2 cosine of 4x minus 4 sine of 4x. Sure.
I did.
Exactly.
Is that okay? I'm gonna ask you to take a derivative of this. How do I take a derivative of this one?
Fraction.
Good. Keep on going. Good.
Are you rushing?
So can I split this?
Yeah.
So can I change that to e to the 2x? Because 3x minus x is 2x. Is that okay? This is e to the negative x because it's below there. So I haven't taken a derivative, have I? So then I'm going to do 2e to the 2x. The derivative 1 is 0. And this one's plus e to the negative x. And that's the final answer. I'm going to talk about one last thing very quickly, but I'm just going to talk about first steps. Let's say natural log of x squared times y might equal to e to the x plus 2y. How do I take a derivative of this? What I can do, what do I do first step?
Why is it plus e to the negative x?
Because if you take a derivative of negative x, it's negative 1. Okay, so what I will do first thing, I will say 2 ln of x plus ln of y. I will not do natural log of both sides because I will just do this. And I'll take a derivative here. It's going to be 2 over x. This one is going to be dy dx over y. But this one you have to be careful. It's e to the x plus 2y times 1 plus 2 dy dx. Because derivative of x plus 2y is 1 plus 2 dy dx. And I will solve for dy dx. If you have to go, you can go, but I'm going to finish a problem on the stream. This one's, I'm going to distribute it. And I'm moving all the dy dx on one side, so it'll be 2 over x minus e to the x plus 2y. And I'm going to factor out the dy dx on this side, so it'll be 2 e to the x plus y minus 1 over y. Now move it over, so dy dx is equal to 2 over x minus e to the x plus 2y over 2e to the x plus y minus 1 over y. And I think this is a great answer already, but if you want to be even more perfection, you can multiply x, y, top and bottom. So that's equal to 2y minus xy e to the x plus 2y over 2xy e to the x plus y minus x.
You actually like not my test tomorrow. Actually, made my day.
I don't know. You probably won't say the same thing by Wednesday.
I don't really care how I feel.
Well, I hope you feel better.
Praying that you would because I worked like 2 9-hour shifts like back to back. I worked Friday, I worked Saturday and Sunday from 11 to 8. I got home, called William, literally until 12, tried to do homework.
Well, you should have done that last week, last Friday.
Like, praying.
William's such a nice guy. I believe you. You have very good at finding mistakes.